Hello. In today's video, we'll take on the full process of designing, 3D printing, and assembling a custom Dodge Challenger RC car from the ground up. Derby Rapid Adhesive is used to bond the printed parts, and the bond is instantly cured with the help of an activator. After construction, the shell is sanded smooth and layered with polycarbonate plastic putty mixed with hardener for surface refinement. A coat of Best Elite Matte Spray provides strong coverage with excellent protection against weather and wear. We rely on the Artillery Sidewinder X2 printer to deliver precise 3D prints with impressive detailing and refined surface texture. 𝐬𝐮𝐬𝐜𝐫𝐢 PLA+ is chosen for its reliable strength, smooth printing experience, and premium finish quality. The body receives a vibrant coat of bright yellow, applied uniformly to ensure a flawless and even base layer. Using a paint gun allows for superior coating, precise control, and a finish free from brush streaks. Details like wheels and trim pieces are coated in black to create a dramatic contrast with the yellow main body. Masking tape is carefully laid over the painted surface to define the areas designated for black racing stripes. These sleek black accents are styled to mirror the iconic look of real Dodge Challenger performance models. Meticulous masking and controlled spraying are key to producing clean edges and a high-quality finish. A batch of piano black paint is prepared for use in the custom stripes, aiming for a mirror-like, high-gloss effect. The stripes are airbrushed onto the masked body, covering just the planned sections with precision. This painting phase enhances the scale accuracy, visual richness, and durability of the final RC car. After curing, the masking tape is peeled back to reveal bold, clean-cut black stripes over the bright yellow base. 𝐟𝐸𝐺 G3 Professional Paste is polished into the paint using a foam pad attached to a rotary drill. This stage removes any minor abrasions, restoring clarity and improving the surface's optical depth. The result is a lustrous, showroom-caliber finish that's ready for sealing with a protective coat. Small M3 screws are then fitted to firmly attach individual elements and complete the RC car structure. With the rear windshield in place, the RC car's upper frame now appears complete. The side doors are then attached, complete with tiny mirrors for a lifelike and finished presentation. A transparent top window is added next, carefully aligned with the car's roof to enhance realism. Installation begins with mounting the rear spoiler to improve the vehicle's appearance and aerodynamic efficiency. Side skirts are matched to the base and fastened securely on either side of the lower frame. To finish the shell, both front and back bumpers are fitted, giving the model its complete body shape. Next comes the chassis stage, where a 1/10 scale frame is prepared to provide support and better functionality. Sakata 850 filament is used to print the base chassis due to its durability and resistance to heat buildup near the motor. Utilizing 3D printing minimizes production expenses while enabling rapid customization of finely detailed parts. This technology dates back to the 1980s and has since undergone massive improvements in quality and speed. Through 3D printing, it's now possible to fabricate intricate designs and reduce overall weight, which proves ideal in the fabrication of compact vehicles like RC cars. RC builders rely on 3D printers to create bespoke parts such as panels, brackets, and mounting hardware. Chassis elements are then precisely positioned and secured using a standard M3 screw kit. To power the steering, a DC58 21LV 20 kg digital servo is installed for powerful and accurate response. Its waterproof design ensures it remains unaffected by wet surfaces or water encounters during driving. This servo combines strength with precision, allowing the RC car to stay controllable even under high-speed conditions. This servo can handle up to 20 kilograms of force, making it capable of executing sharp turns and quick maneuvers. It's built with advanced internal components that promote long-term durability, quick reaction times, and minimized overheating during extended use. RC car customization is a global hobby enjoyed by enthusiasts, racers, and builders from all walks of life. Historians trace the rise of RC car popularity back to the 1960s, when clubs and competitions began to emerge. Today, the hobby continues to grow thanks to online groups, content creators, and social media interaction. Creating an RC vehicle demands a working knowledge of mechanics, electronics, and a fair amount of patience. The next step includes installing a 540 brushed motor 55T, known for its strong torque and dependable output. Gears are then assembled, with grease oil applied to enhance performance and prevent wear over time. Wheels are fitted with rims and secured to ensure balanced motion and structural stability. Authentic Michelin decals are carefully applied to the chassis, adding realism to the final design. To regulate speed and power, a Hobbywing ADA brushed ESC is connected to the motor and electronics. A secure SQ001 mini soldering iron is then used for detailed, accurate soldering of wiring and terminals. Its heat control is managed by a smart algorithm that offers compensation features and auto-calibration. Red 5mm LEDs are mounted to the vehicle to boost visibility and visual appeal. These bright LEDs make the 𝐟𝐨𝐫 car stand out at night and simulate real lighting functions. To recreate authentic lighting, the Tamiya LED light kit is installed for both front and rear ends. Headlamps, brake lights, and indicators light up realistically through the use of this kit. The light system draws power from the car's main battery pack, eliminating the need for extras. Connectors and wires are built from rugged materials that resist heat and vibration during operation. A lighting control module is included, allowing different light patterns to be triggered based on driving actions. Its compact, lightweight design ensures the 𝐟𝐶 car's overall mass remains virtually unaffected. Though water-resistant, the kit should not be fully submerged to prevent internal damage. To enhance realism, the Sense ESS dual-engine sound simulator is integrated for dynamic engine audio during motion. This sound unit syncs with throttle input to boost immersion and deliver real-time engine feedback. For better signal precision and responsiveness, a 6CH iBus PPM receiver is installed. A 𝐶HL-3S 1500 mAh LiPo battery is used to deliver steady, efficient power throughout the session. Wiring is meticulously arranged so all electronic systems function together without issues. Once assembled, the 𝐟𝐶 car undergoes field testing, and its top-tier performance is validated. It handles acceleration, grip, and responsiveness impressively across various terrains. Maneuvers remain fluid, and the car continues to perform at a high level under extended use. Its lifelike features and commanding motion instantly capture attention. This finely tuned model offers not just speed, but lasting enjoyment and visual appeal.